Hello and welcome. This is me, Ahmad Khan, once again. Um, in today's lecture, we will talk about remote process code injection, what it is, and how we can perform remote process code injection. Um in this lecture, we will target Notepad++ and we will generate a shell code by using Metasploit, and then we will inject the malicious code to Notepad++. That will be a legitimate process, and then we will try to get a reverse connection and architecturally controlling on that particular system. So let me talk about what is process injection. Basically, process injection is a set of technique that is used to inject a malicious payload into a running process to avoid some detection. Uh, Everyone know about like there are some security like firewalls, vendor defenders, and other system security that are able to detect any malicious activity. For this particular purpose, remote process code injection will help us to avoid like firewall protection, like some other protection. Uh, this will be legitimate because our process will be totally migrate to a legitimate. Sorry, I mean our payload will be totally transferred to a legitimate process. So you can see here from the diagram, we have a dropper. Basically, dropper is a malicious software uh, which generate a request to a server in order to download a particular payload from that server and then execute it hiddenly on any system. It's clear from the name dropper, which drop a malware in simple word. So we have a dropper and we have shellcode inside our dropper, which will help us to get shellcode from a server. Basically, we can host the shellcode on any server in order to get the direct downloading URL. So I'm not going to talk about this uh, because the topic is about remote process code injection. So this dropper will help us to get the shellcode. What we will do, while on the other hand we have notepad.exe, which is basically our target software or target process. First of all, we will create empty buffer and the process. Like you can see here, this is the process. So we will create empty buffer and the process for our dropper, for our shell code, and are to place and are to inject the shell code and that particular buffer. The size of the buffer will be well equal to the size of our shell code. Like the size of the shell code will be equal to the buffer, because we will place our shell code inside this empty buffer and are to inject this shell code into a process. Reason is that for the shell code we need memory location. We have to allocate and we have to store our shell code somewhere in the memory. For this, memory location is required. For memory location, we have to create an empty memory buffer, which will help us to keep our shell code inside this process. So when we will create an empty buffer, when we will successfully place our shell code and empty buffer, shell code will be there. Like it will be something like this. If I'll copy this and if I will place here, you can see the final result will be like this. So now you can see here notepad.exe process has a shell code. So if it will under process, I mean the notepad, if the notepad will under process, notepad will be able to execute our shell code. By doing this way, we will be able to, the shell code will gives us a remote connection and to that particular system. And also one way to do the process is to get a persistent connection. So we will see how we can do it. The first step is to create a malicious injector by using C programming language. So by using C programming language, we will create a malicious code injector which will help us to inject malicious code to any process. So you can see here I'm using a code block ID. Inside a code block ID, I will write my own injector. So first I will include std.io library. For this purpose, I will type #include hash include stdio.h. This is the library for C programming language. And also we will include Windows library for Windows. So I will type windows.h. Right now we have successfully included the first two main library to our C programming language. Now I will write something inside main function. So I will type init main for the main function, and this will be the body of the main function. So right now what I'm going to do, I will write the code. The first step is to create a shell code. The first step is to to inject the shell code into a process, because this is an injector which will help us to inject our shell code into a process. So for shell code, what I'm going to do, I'm going to create character array. So the array will be shell code. This is the name of the array. For now I will keep this an empty. The reason is that first I will write the important part of the code, then I will generate a shell code by using Metasploit framework for C language, and then I will place the shell code over here. So right now what I'm going to do, I'm going to create a variable that will handle our process. For this I will type the name of the variable will be like exec process. So this is the name of the variable, and the data type of the variable will be handle, because this variable will help us to handle the process. So right now what I'm going to do after this, I'm going to create a exec thread which will handle thread for us. For this I will keep the name of the variable exec thread, and the data type of the variable will be handle also, because we wanted to handle this variable will be able to handle thread for us. After this what I'm going to do, I'm going to create another variable with white data type, and this will be exec memory, which will help us to allocate memory for our process. This will be the name of a variable. Right now I will store something in this variable. I will store some instruction inside this variable. So for this, first I will call the variable name, and the variable I will keep this equal to open process. I will call this in built-in function open process. This function will help us to open a process. This function takes 3 arguments. The first one will be process underscore all ss, which will assess all the important component of the process. Like our process is notepad exec.exe, so this will take all essays of the notepad, the main important essays of the notepad. So I will keep the second argument true to inherit inside it, and this third argument will be process id. For now I will just view it empty, or I can just visit process monitor. Okay, I don't have process monitor. I will use resource hacker. I have to download it, but I will keep it for now empty. Now the second one is basically the exec memory variable, which will allocate some memory for our process, for our shell code inside process. So for this I will call the variable name exec memory equal to, I will use virtual allocate function. This function will help us to allocate memory buffer, memory inside any process or target process. So the first argument will be we want to allocate memory for exec process, and the second one will be null, because I wanted to keep the protection for now. It will be just wrong. So Then I will define the size of the buffer. The size of the buffer, as I said before, the size of the buffer will be the size equal to the size of the buffer will be equal to the equivalent shell code. So what I'm going to do, I will define size of buffer will be equal to shell code size, and then I will use another argument for memory locate, and this will be mem commat. I will pipe this, and I will what I will do, the another argument will be after piping, another will be mem underscore release, reserve, because we want to reserve the memory. And then we will use protection. This will be, I will use page underscore execute read write. So now what I'm going to do, I think I'm so sorry, I'm confused about this. I will keep it page execute read write because we want to read and write, I think so. So what I'm going to do right now, we will write process memory. We will write the memory for the process. So for this I will use a function write process memory, which will help us to write the memory. So for this function will take some argument. So the first argument will be which process. So I will use exec process because we wanted to write memory for this exec process, and then will be the memory location that we want to locate. Third one will be for what? For shell code. Okay, and fourth one will be size of the buffer. As I said before, the size of the buffer will be size of shell code, and it's fine. And the last one will be basically the protection. I will keep it null because I don't need it any protection for this. Now the last step is to create a thread. We will call the thread the thread variable, and this will help us to create remote thread for this particular task. So what I'm going to do, I'm going to call the thread is exec thread, which is equal to, I will call an embelton function create remote thread. This will take some argument from the user, from us. So the first we want to create a thread for exec process. This will be the first, and the second one I will keep it null because of the any protection like. And then the third argument is for the LP thread start routine. So what I'm going to do, I'm going to use that LP thread start routine. This will be the next argument, and then what I'm going to do, I'm going to call the exec mem, which will basically allocate memory for our process, for our shellcode inside the process, and the protection will be like now. So this is fine. And the last argument I will keep it 0 and 0. That's fine. Now I will close the handler. So I will call close handler function, and what I'm going to close, basically I'm going to close the process, which is basically exec process, and the return time of the function will be return 0. So now that you can see we have completed the code of the injector. Right now we will generate a shell code which will help us to give a reverse connection. To that shell code we will be able to tactfully control our Vectrum system. So for this purpose I will use Metasploit, which will help you to generate C language shell code. You can use any other framework depending on you, but I think Metasploit is best for this. So I will open my Call Linux operating system, and I will open the terminal to generate Metasploit based C language shell code. So first I will use msfvenom. msfvenom will help us to generate a shell code. So I will type msfvenom hyphen ps for payload. Which payload I wanted to generate? I want to generate Windows payload and backslash. And after this, we will specify the architecture of our target operating system. So architecture will be x64, and I will specify the shell code name, I mean the vector name. So I want shell, reverse, and TCP. Then I will set the lhost. This will be basically our IP address. Through this IP address, we will be able to receive an incoming connection. So I will type ifconfig for this to find out my system IP address. I will copy this. I will paste here. Now I will specify the port. So the port will be like 444, and I will specify the file. The file will be C. Basically, we want to generate a shell code which will be totally based on C language. And also, while on the other hand, I will start Netcat. Netcat is a Swiss-based tool which will help me to receive an incoming connection. So I will type NC for Netcat, and I wanted to start a port 444. This will be my listening port. I wanted to receive an incoming connection from my target system through this port. So this will be listening port. So I will hit enter to listen this port. You can see here now this port is listening, and while on the other hand you can see here we successfully generated the shell code. So I will copy the shell code. I will copy, and I will save this in a txt file, and I will move this txt file to a var www.html folder, and then I will host the file to receive the file, I mean to get the shell code. So I will type cd var www/html, and I will start service Apache 2 as well for hosting, and then I will generate a file. The file will be shellcode.txt. I will hit enter button. I will paste the copied shell code. You can see I will save the file. Cool. So right now what I'm going to do, I'm going to if I type ifconfig, I will type the IP address of this system and my own primary operating system in order to get the shell code. So the IP address is 192.168.19.129. So I will type the IP address 192.168.19.129. I will hit enter button, and you can see here shellcode.txt. If I will click on this, you can see I got the shell code. So I will copy the shell code by pressing Ctrl A, by pressing Ctrl C. By pressing Ctrl A, I will select the shell code, and by pressing Ctrl C, I will copy the shell code. I will visit the code of my C programming language, and you can see here inside this empty array, I will paste the copied shell code, and I will remove the semicolon. Now it's fine. We have successfully placed a shell code inside an empty array. So right now, the only thing is to specify the process ID here. What I'm going to do is, I said before in the starting of the lecture, I will target Notepad, but I think it will be better if I will target like any browser. You can target, don't worry about this. You can target any application depending on you, but right now I'm thinking to inject this code into like Microsoft Edge. So what I'm going to do, first of all, I will find the I will find the process ID of Microsoft Edge. For this purpose, I will open resource hacker, which will help me to find the process ID. I mean the process ID application. I mean, so I will type resource hacker, not resource hacker. I will type process hacker. You can see I will open it. So I will maximize this. I will type here Microsoft Edge. I will open, first of all, I will open Microsoft Edge, and I will type Microsoft Edge. Sorry for the spelling mistake. I will hit enter. Cool, you can see here we got it. So you can see the process ID is 83656. So I will minimize this. The process ID is 83656. 83656. 83656. Perfect. So now what I'm going to do, I have to build this code injector. So I have to click on build. You can see here. Cool, you can see. Perfect, we have done it. So what I'm going to do, I will visit the folder where I have this. So if I will click on Ben, if I will click on debug, you can see here we got the output exe code injector. So I can rename this to a code injector. That's fine. So if I will visit my Kali Linux, I will put the password, and you can see here netgate is waiting for incoming connection. What happened if I will execute this code injector? Cool, you can see we got the reverse connection. So if I will type dir, I am able to read all the files, folders from the vector machine. I have remote access to the vector machine. I can download any folder, I can download any type of data files from the vector machine. I am able to remotely control everything from the vector machine, totally silently and inherently. So what I'm going to do, if I will visit resource hacker again, if I will right click, if I will click on properties, if I will maximize this, now what I'm going to do, I will visit memory. I will search for read and write protection. So I will scroll down, and as you can see here, read and write, this is the private. This is basically our shell code which is successfully injected into this process. So if I will double click this, you can see here we got the code. If I will maximize this, this is what you can see is the shell code which we have injected. So the first value of the shell code is FC. So if I will visit my C programming language code, you can see here FC, X is represented, X represents that this code is, this is hexadecimal, this is a hex code. So FC is the value, X, if you will like see, if I have, let me explain this point. If I have variable like init var, if the value of this variable x is x o f, like something like this, it means that the value is hexadecimal. So you can see here, this is the hexadecimal, this is a hex code, FC is the first value, and you can see this is the FC. So our shell code is successfully injected into the buffer of process. You can see here our shell code is starting from here and ending at this value. So this is basically we have injected a shell code into the process of Microsoft Edge, which will be in the buffer of this particular process. I hope this concept will be clear to you. If you have any problem, you can let me know. Feel free to ask if you have any question. For now, I think this is enough. Thank you very much.